Aloha to the C, E, and M kiddies, the second year AP folks, calculus based, just checking in, giving you some more resources to help prepare for our celebration, which hopefully you have this down already. The E and M, it will be on May 11. That will be when we get to hang out and do our celebration of epic proportions. Now, hopefully this is also not the first time you've seen this particular set of stuff, units 1 through 3 and then 4 and 5. All right, that tells you what they will be testing you over, and this year's a little unique. The subject matters that they won't be testing you over. But if you don't know what units 1 through 3 and then 4 and 5 are, that's bad, because I'm a teacher who cars, and way back at the beginning of the year, I put these documents on the Happy Schoolo Lology page. The AP Physics E&M course at a glance, and then this is the much more detailed version of it. But the course at a glance document is a PDF that came straight off of the AP site. What it tells you again is what topics 1, 2, 3, 4, and 5 are, and the first thing they will cover is electrostatics. That should make sense. Coulomb's law, remember that's the K, Q1, Q2 over squared. All right. Electric fields and electric potential, and we probably remember drawing electric field lines as we brought point charges closer and farther together. And then what do we have? Potential due to charges in uniform fields. So again, as you move through that electric field, your potential changes because you're getting closer or farther from something that is positive or negative. Please remember Gauss's law. Holy shnikes. You'll get a Gauss's law one, and then fields potentials of other charge distributions. That's if it's not a point charge, maybe it's a piece of sheet metal that is charged, maybe it's a sphere that's charged, maybe it's a wire, maybe it's a semicircle. Things along those lines are what that refers to. They can certainly test you over capacitors and dielectrics. Remember capacitors, those parallel plates, usually it's just air in there. Sometimes they'll put a different substance in between those two parallel plates. If so, then that substance is simply called a dielectric, right? And then electrostatics with those conductors, capacitors, and dielectrics. So it's pretty much just the math associated with that. Please remember Q is equal to, very good, CV, all right? And then circuits, obviously, that is something they're going to test you over. Current resistance V equals IR. Resistivity is rho L over A. A resistance is rho L over A. Resistivity is rho. And then that can change with temperature. Electric circuits, current LP equals IV. V squared over R, or I squared R is the power. Steady state, again, is when once capacitors are charged or whatever is current, once it becomes a consistent current flowing through that circuit. That's what steady state refers to, okay? And then electrostatics, again, they put that in there. That's probably discorrect to have it written there. But then these magnetic fields, and it's funny, the name of the class is electricity and magnetism, but I guess topic number 5, you're not going to do much with induction, Maxwell's equations, Faraday's and Lenz's law, which is the negative sign. Ooh. But anywho, I can't imagine not having a B.O. Savart law going on in there, but they said numbers 4 and 5 aren't going to be covered. But anyway, please, hopefully you guys have seen that before, okay? then what I'm going to do is take us to this channel here, okay? You guys hopefully have not, or hopefully have seen this before. This is not the first time you've seen it. This is every AP subject that is out there. Look at all those art subjects, huh? That's a lot of art right there. And then the unrelevant ones, huh? Then you got AP US. Ooh, there's government. There's an unrelevant one for you. Psychology, yeah, it's all in your head. There's the two calculi ones, the AP stats. And down here are the physics ones. All right, so physics 1, chem, APC. There's the E&M, and then there's the physics 2. But this one, then, if you click there, that will take you to these set of videos, which this may be the first time you're looking at these. This is obviously the playlist that, gosh, these AP folks are generating to help people just like you get smart for May 11. Um, and so this first video, E&M capacitors and circuits, it's scheduled to go live on May 1st. So they will be giving you a live broadcast about that May 1st. April 30th will be DC circuits with batteries and resistors, but that can't be that hard. More circuits with batteries and resistors. So these again are scheduled for the 28th. Today is the 27th here, so it's 6 o'clock. They'll give you some P equals IV. And then as you see down here, where it says there's a 51 minutes, 21 seconds. This is current and resistance. So they did post these already. And these are, again, places where I would think this is where you want to be going, okay? This is the reason I created this video, was to show you these videos. But current and resistance, please get to know that. And watch those videos together as one. Numbers 6 and 7, that's one topic there. Numbers 8 and 9, you can tell capacitors part 1 and 2. This is where real honest to goshness AP physics teachers will give you real honest to goshness notes and lectures and diagrams and sample everything. All right, dealing with capacitors. So numbers 8 and 9 go very well together as one topic. All right. Look at numbers 10 and 11. The electricity and magnetism potential of concentric conductors. Okay, this is probably going to be, again, another Gauss's law one, where if you have concentric spheres or circles, they're charged rings, whatever, what is the electric field inside there? What is the potential associated with that? How positive are you? And as you move through those, what does your potential do? How does that voltage change? So there's another one. So there's 10 and 11 go pretty well together. 12 goes well with that also. And then uniform electric potential energy is another one that you're going to want to know. Gauss's law. So I would put 11, 12, 13 together. Take a look at 14 and 15. Okay, Gauss's law, and then Coulomb's law again for electrostatics. So Gauss's law, you're going to want to remember Gauss's law. Conductors and insulators, again, they behave a little differently in terms of what their charges can do and where those charges go once they're placed on the object. And Coulomb's law, again, you already know that's the Q over R squared. All right. Video 16 and 17 I think go well together. The fields due to charge distributions and flux. All right, so this could be electric field, flux, and Gauss's law for a uniform charge. So again, flux just refers to the number of field lines that pass through an opening. So if you could draw an imaginary Gaussian surface, that's just an imaginary opening a certain distance away from a charged object, all of the electric field lines will pass through that entire thing. So the Q that is enclosed will be all of the Q, all right? And over epsilon 0 equals the integral of the electric field times the differential area, which the area is just the area is the area of whatever Gaussian surface you care to draw or needs to be drawn. If it's a circle, draw or a sphere, draw a sphere. If it's a wire, draw a cylinder around the wire. All right. And other charge distributions, then that refers to things that may not be a nice wire. It could be a semicircle, or it could be a half disc, or something along those lines. But 16, 17 go well together, uniform charge distribution, and 18. The electrostatics and electric field due to point charges. Again, that's the electric field gets weaker as you get away with distance. A point charge is just that, something that's a sphere that's fixed in space. Its charge is radiating. It's got field lines going outwards in all their x, y, and zetians. That's what a point charge is. If it's not a point charge, maybe it's a charged rod or a charged wire. That's when, again, you would use Gauss's law. I don't think they would have you do them vectorially. That would seem to be a tremendous waste of time for this particular year, but I'm pretty sure they're gonna throw some Gauss at you. They're gonna throw some Gauss at you. All right, and then those field lines. So 18 and 19, I think, go very well together. But then once you get to 20, see how number 20 again talks about Maxwell's equations, and then inductance, RC, which is resistors and capacitors, RC circuits and electromagnetic induction. I would have to think RC circuits. Number 22, you're going to want to get to know when you put a resistor and a capacitor in a circuit. So I think 22 is kind of out of place. It could be moved up a little bit, but RC circuits are circuits that have both resistors and capacitors in them. And I remember we did a test over RC circuits already. But this is, again, it could be part of remember how we calculated the amount of time it would take to charge a capacitor or discharge it was having an RC circuit, right? And using Kirchhoff's loop rule to get the amount of time it took to charge or discharge. So that was RC circuits. You're going to want to know video number 22. But I think the induction, the Ampere's law, magnetic fields of long carrying wires, those other ones, I think they put them on there just to kind of finish up the year. They knew that maybe a lot of classes didn't quite get all the way through the curriculum yet. So those ones are ones that you may not need to know as much for May 11. But again, I would definitely go through number 22. All right. So again, I'll go back up to here. Capacitors and circuits, when those go live, you're going to want to get through these first 5. And then starting 6 are the ones that you can start going over right now. As you go through those, I said watch them in that kind of grouping. Once you've watched them in that kind of grouping, what you can do is go back to the Schoolo Lalo G page, and you can say, well, wow, okay, here's the electrostatic sheet. You can go through some of those review sheets. There's the circuits ones that go through some of those review sheets. And then that video at the bottom is when I showed you some of these items before. But again, as you go through those topics in those particular groupings, like I had said, where are we at here? This is the 2, this is the E&M. Then another place to go to start doing some math is this, because this has all kinds of very specific types of questions and problems that are associated with that. So any given topic of this, like this one I just opened to, those charts and graphs that should look familiar for you, that's a resistor and inductor, but you don't need to do that. But then this has all kinds of things to do. So what you can do again is go through those videos. They were created by real AP physics teachers. All right, and they're going, I mean, at this page you're looking at right now, that is where you need to be, okay? But anywho, hopefully you're still there. We'll keep in touch. Feel free to email. I'll put some more stuff out there, and yay, physics!